Hello people, Zach here again today, and this video is going to be a short follow-up to one of my previous videos, specifically the one refuting Sabina Hossenfelder's argument that an accelerometer held in your hand registering an upward acceleration is somehow evidence or proof of gravity not being a force. Now that video blew up way bigger than I ever thought it was going to. Like, it's now my #1 most viewed video, and I have no idea why, because it is by far the least interesting video out of all the ones I've made. Maybe it has something to do with Sabine's name being the title. That's the only thing I can think. Now, there's a lot of negative reactions to the video, which is fine. You know, people have their own opinions. They're going to believe what they want to believe. But what was really funny about it was that, like, most of the comments that were people responding negative to the video had, like, nothing to do with the content of the video at all. Maybe it's just because of the fact, like, there was nothing really refutable about what was in the video. No, I'll take that back. There was two comments in the entire comment section that had anything to do with the video. One was that this doesn't actually disprove Sabina Hossenfelder's argument, which it does. It does so in the last minute of the video. Most of the video is building up to basically proving the equivalence principle for springs. And the last minute was just an appeal to common sense regarding, like, what you can see versus what you can't see. But the other argument was talking about a spring in free fall, and, like, if a spring doesn't expand or contract in free fall, that somehow that's proof that gravity isn't a force. Now, I'm going to go ahead and tackle both these points. The very first one, we're going to be talking about the equivalence principle, because I don't think that people understand what the equivalence principle means. When you say that two things are equivalent to each other, what it means is that you can substitute one in place of the other and vice versa. When you see 2 plus 3 is equivalent to 5, right? What does that mean? It means that everywhere that you see 2 plus 3, you can substitute 5, and it still works. And it means that everywhere that you see 5, you can substitute 2 plus 3, and it works. It works both ways. That was what it means to be equivalent. The equivalence principle does not mean that general relativity's explanation for the phenomena is correct. It means that it is valid, that you can represent it that way. But just because it is valid doesn't mean that it's sound, because valid means that it's logical, like you can actually work out the math and show that it is self-consistent. But being sound relies on sound reasoning. And this goes into the second part that we're going to talk about here, which is gravity being a force. So people say all the time, gravity's not a force, gravity's not a force, gravity's not a force. And to these people, I will ask you the question, what is a force? What do you think a force is? Because forces are defined. They are defined by Newton's laws of motion, specifically the very first law of motion, which is a body at rest remains at rest unless acted upon by a force, and a body in motion moves in a straight line at a constant speed unless acted upon by a force. Now, experiment here. Did it remain at rest? No. Well, it was in motion, right? Well, was that motion in a straight line at a constant speed? No. It did move in a straight line, but it was not at a constant speed. It was increasing at a rate of 9.8 meters per second squared. Therefore, it is a force. That is what a force is. Newton invented calculus for the explicit purpose of figuring out how gravity works. Do you not think that he knew that gravity was a force? Like, come on, people. Come on, keep up. Now, addressing the argument about the spring not expanding or contracting as it's falling as somehow being evidence of the force, for the spring to expand or contract, that means that there has to be a difference in the force between the head of the spring and the tail of the spring. The fact that there's no noticeable difference enough to overcome, like, the spring a spring constant to actually cause it to expand or contract is not proof that there's not a force, because the fact that it's falling at all, the fact that the spring as a whole is falling, is proof that it is a force by the very definition of what a force is. So, anyways, that's pretty much all I want to talk about in this video. I mean, I could probably go into 100 million different tangents addressing different points in the comment section, but most of those have to do with general relativity, like people arguing about what about this? What about this? What about this? What about this? Which isn't really related to the topic of that video. I just want to address this point. The gravity is a force, and me rejecting general relativity is not me subscribing to any other theory of how gravity works. Like, I do not subscribe to Newtonian model of gravity. The idea that it abides by the inverse square law. And the reason why I don't subscribe to that particular idea is because I believe that the inverse square law has more to do with the expansion of point source radiation being relative, like, I mean, the intensity of point source radiation being relative to the expanding surface area of a sphere for a point source emission. And gravity is obviously not a form of radiation, so it doesn't make much sense to me that it would abide by the inverse square law. To me, it seems more like it might have something to do with mass distribution, in which case you're looking at more of something that's like the Planck distribution, which is a 1 over e to the x minus 1 law. And that actually, when you're talking about distribution, now you're talking about like entropy. So this is kind of like in line with entropic gravity. And this 1 over e to the x minus 1 term that you would see, that is actually a very close approximation of 1 over r squared for like small intervals. But then it diverges at certain points, which means that basically once you get to certain scales, gravity almost appears to behave differently, which is what Mond says. Mond says that gravity behaves differently at different scales, like at certain extremes. So that would explain things like the weird orbital path of Mercury, or like why the spiraling arms of galaxies are moving slower than we expect them to, or something like that. It's because it's not a 1 over r squared term. It has more to do with like the distribution of masses. And it also kind of ties in with like Mach's principle regarding like the origin of inertia being related to all of the masses in the entire system. But anyways, like I said, I don't subscribe to any particular theory because none of them really seem to be completely accurate. I also don't subscribe, just to be clear, I do not subscribe to ether fluid mechanics of gravity, because I don't believe that the ether is a fluid. I don't believe the ether flows. I don't even believe it's capable of linear motion. If you want to hear more of my ideas about what the ether are, I made a video about that not too long ago. I think it was like Proof of the Existence of Ether or something like that was the title of the video. It's not fluid mechanics. It's something completely different. But anyways, I think that's pretty much all for this video. Thank you for watching.